Hello students, I hope that you are good, well and fine. In today's session, we will be seeing NCERT exercise 5.3. So far we have discussed enough theory to now solve this exercise, NCERT exercise 5.3. So let's jump to our first question, which says that we are uh, asked to find the derivative of this implicit function. For now, the one way is to write it down in the explicit form. Otherwise, the method we just saw in the previous session about the implicit function, we will use that. So just operate your dx to both sides, then you will get this will become 2, this will become 3, y dy by dx is equals to, this will become cos x. Now dy by dx will be what? Very simple, cos x minus 2 by 3. That's it. You will get your answer as dy over dx. Okay, so your dy over dx will be this. Simple. Okay, I hope that you remember how do we get it here. So we just operated dy over dx to both sides, to the left side and to the right side, and you will get this, and after that you will write your dy over dx is equals to some expression in terms of x only, in terms of y only, or in terms of x and y together. Okay, I hope that it is clear. Okay, the first question, simple. So first few questions will be simple of this exercise, NCERT exercise 5.3. Now the second says the same question, the same pattern will follow. You will operate your this thing to the right hand side. Okay, to the right hand side and to the left hand side. Simple. Now as you know, this will become 2. You have y, so you can easily write dy over dx. Just follow the rules. And if you are having any expression, anything, any function, any such sort in terms of y, then what you have to do, just derivate this thing in terms of y. Okay, then you will get cos y, and then what, just multiply with dy over dx. That's it. You have to do, that's it. Now manipulate such way that you will get dy over dx thing. Okay, so how you are going to manipulate? Very simple. It will be 2 divided by, you take this to the right hand side and you will get cos y minus 3. Okay, so the final answer or the derivative of this implicit function, you will get dy over dx is equals to 2 divided by cos y minus 3. Okay, simple, easy. So what we use chain rule obviously, but you didn't notice how we use when we use, so don't worry. Okay, you have to work that much that you will get to your answer, only that. Okay, and if you follow my instructions, you will get your answer without any error. Okay, now let us move to next, third problem. Here a, b are some constant numbers, some constants, and x, y are variables, as it is what your implicit function. Okay, so how you are going to use? Obviously you have to apply it, the operator, in this manner. Simple. Now what will be your next step? Just derivate it. You will get, I will be just skipping step in between steps. You will get a plus this will be, so now here it is not written just y, it is written y square. So what will be your steps? So steps will be just quite simple. So first of all, derivate the expression, so it will be 2y. Now multiply dy over dx. That's it. Whenever you have any expression of y, okay, then you just have to derivate it and then multiply with dy over dx. Okay, simple. Okay, now this will be, as you are having what your y term, then this means this will be, first of all, derivated, you will get minus sine y, and now just multiply with dy over dx. That's it. You have to do this thing only. Now take dy over dx common. What you will have, let's see. So dy over dx taking common, I am taking this left hand side thing to the right hand side thing to the left hand side and manipulate it. You will get minus of a divided by sine y minus plus 2by. Okay, you will get this as your derivative. Okay, simple. Okay, so what you are using again and again in implicit function, you are using derivative operate dy over dx to both sides and then derivate with respect to x. If you are facing any term, any expression with the term y, then what you are doing? You are doing just simply derivating it with respect to y and then multiply with dy over dx. That's it. Okay, that's it. Okay. Now, question number 4. What question 4 says? That xy plus y square is equals to 10x plus y. Okay, very nice. So operate it. What you will do, by operating, I will just write directly. So dy over dx, it will be like this form. Dy over dx, it will be like this form. Dy over dx, this will be like 10x, derivative will be sec square x if you remember, and this will be dy over dx. Okay, why? Because derivative of y is 1 multiplied with dy over dx. That's why I simply wrote, whenever you see y, just write dy over dx. Okay, the logic is same. Okay, you first derivate it with respect to y. What you will get? 1 multiplied with dy over dx. The same thing. Now here we will use what? Product rule. In product rule, if you remember, u multiply v, derivative is just nothing. Make anything untouched, derivated the other term, now plus derivate the second thing, and first thing will be untouched, like this. Okay, you will have this. So this will be what? That first of all I will derivate x. So it will be 1 multiply with y untouched, now plus, now x will be untouched, now derivative of y, this will be 1 multiply with dy over dx. Okay, now this will be derivative of inside thing, which means this, so this will be dy over dx. Now sec square x plus dy over dx. And now take all dy over dx things together and take out the common things, which is dy over dx, and put it equals to some expression. So what you will get? You will get y divided by dy over dx will be, as you can see, sec square x minus y divided by, as you can see, you will have x minus 2y. Okay, 2y, x minus 2y plus 1, this sort of thing. X minus, okay, sorry, this will be minus, this will be plus, so x 2y and minus, so x square minus y divided by x plus 2y minus 1. You will get this as your derivative of this implicit function in the question 4. The xy plus y square is equals to 10x plus y. Okay, I hope that it is clear to you. So let us move to the next problem. Problem number 5. Problem 5 says that find x square plus xy plus y square is equals to 10, the derivative of it. So derivative of it will be very easy. So first of all we will use the operate, then I am just directly writing. Here we will be using what? The product rule. The product rule says that y plus x dy over dx plus 2y dy over dx is equals to 0. Now take dy over dx common. You will have what? You will have minus of 2x plus y divided by x plus 2y. This thing. So your answer will be 2x plus 2y divided by x plus 2y. 2x plus y divided by x plus 2y and the minus sign. Okay. Clear? Okay. So this means the derivative of the implicit function given in the fifth problem will be minus of 2 in numerator 2x plus y and in denominator x plus 2y. Simple. What we just use the product rule, we just use the implicit theory. That's it. Okay. So problem number fifth is done now. Now problem number sixth. Now problem 6 says just same thing. So let me just quickly write it down the derivative. So 3x square plus this will be 2x y plus x square dy over dx. Here I have used the product rule. So this means I am derivating this thing and this will be untouched. Now I am derivating this thing, this will be untouched. Now again product rule, y square plus x 2y dy over dx plus 3y square dy over dx, and the derivative of constant will be 0. Taking dy over dx common, and these terms will be at the right hand side. You will get 3x square plus 2xy plus y square. Now divided by these terms, x square 2xy 3y square. So x square 2xy 3y square. So you will have the derivative this. So minus of 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. Okay, very simple, very easy to write the solution or to find the derivative, or which means dy over dx of the given implicit function in the problem number 6. Okay, let us move to the next problem, problem number 7. So problem 7 says find the derivative. Very easy. So derivating it, you will have to apply the chain rule because of the square thing. So this will be converted to, let me just convert this thing. This will be like this. Okay, now cos xy is equals to some constant. Okay, so xy. So first of all, if after applying this will become derivative, this will be 0. This will be taking inside thing derivative. The inside thing derivative will be using the product rule. You will get y plus x dy over dx. That's it. Okay, derivative of x multiply with this untouched. Now derivative of y multiply with this untouched, and you will have minus of sine the inside thing. That's it. Now derivative of this will be what? Now the inside thing derivative will be cos of y multiply with dy over dx. That's it. Now outside thing derivative will be 2 sine y. That's it. So your answer will be, by taking dy over dx common, what you will have? Dy over dx common, you will have what? Y sine xy, as you can take y sine xy. Now this will be 2 sine y cos y, 2 sine y cos y minus this will be x sine xy. Okay, x sine xy, and this will become sine of 2y. Yes, sine of 2y, as sine 2 theta is 2 sine theta cos theta. So this will be your final answer for this problem 7. So derivative of sine square y plus cos xy is equals to some constant number will be dy over dx is equals to y multiply with sine xy divided by sine 2y minus x multiply with sine xy. Simple. So what we use product rule, we use chain rule. Okay, that's it. These are the simple things we have used so far in from problem 1 to 7. Let us move to the next problem. Problem number 8. Problem 8 says the same pattern thing. Okay, so derivative of this will be 2 sine x and cos x, plus this will be 2 cos y, and this will become minus of sine y. This will be 0 now, sorry, and also the dy over dx thing. Okay, now 0. This means you will have your answer as dy over dx is equals to 2 sine x cos x divided by 2 cos y sine y. You have different way to represent it. You can, one way is sine 2x divided by sine 2y, or another way, can you write it another way? I think no. You can cancel these two, and then one way is to just represent in this form, sine x cos x divided by cos x sine x. Okay, whatever the form you chooses will be the correct if you perform the correct step. So your answer for this 8th problem will be this. So far so good. Okay, let us move to the next problem. Problem 9. Problem 9 says y is equals to sine inverse 2x divided by 1 plus x square. How you are going to use? So one thing, by using the derivative of sine inverse function, which is, if you are given with sine inverse a, then its derivative is just nothing, 1 divided by root of 1 minus a square. So here a is this. So first of all, what you have to do, derivative of this thing. So derivative of this thing, multiply with this sort of thing. So 1 minus 1 by 1 divided by root of 1 minus a. A square means this whole thing is square. So one way is that. But let me just show you how we use the substitution method. So by using substitution method, what can you think? So if you put x is equals to tan theta, if you put x is equals to tan theta, then what will happen? Then it will become 2 tan theta divided by, so y will be sine inverse 2 tan theta divided by 1 plus tan square theta, and 1 plus tan square theta. So far so good. Now what will happen if you try to see? This will be cos square theta, or directly, if you remember, this is just nothing but your sine 2 theta. If you do not remember, don't worry, it will become sec square theta. Sec square theta will become cos square theta. Okay, now tan theta will become sine theta divided by cos theta. This and this will be cancelled. You are having now 2 sine theta cos theta. Now this can be reduced to sine 2 theta. If you remember, then you can escape and directly jump to this. If you do not remember, then you have to go by steps. Okay, simple. So this means, and this means what? That sine inverse sine theta will give you what? 2 theta. Now derivate it. How you are going to derivate it? Quite simple. So first of all, substitute the theta back to in form of x, in terms of x. So you will get tan inverse x. Now derivate it. You will get, now it is quite simple to answer. So it will be tan inverse x will be 1 divided by 1 plus x square. So you will have your answer as 2 divided by 1 plus x square. Simple. So see how you reduced your work by just simple substitution. Okay, so how we are going to find out the substitution? Very simple. Whenever you see inverse trigonometric function, and whenever you see the combination of inverse trigonometric function and some scary looking expression, then always come up with some substitution in such a manner that whole term become reducible. Okay, clear? So if you go through this conventional way or this long method, then the percentage of getting error will be high. Here you will get your correct answer in less time and very accurate and efficiently. Okay, so this is the problem number 9 is having with itself about the substitution. So let me just move to problem number 10, and now we will try to use the substitution so that your substitution part will be strong. Okay, so problem number 10. Problem 10 says, now if you try to substitute it, so this will be of what form? If you try to think, just substitute what you can think. So always, first of all, the thing you always come up with, first of all, you must remember the formulas. The main formula is the cos, the double angle formulas for sine cos tan, the triple angle formulas for sine cos tan. The things which are the foremost things are the double and the triple angle formulas for sine cos and tan. Okay, mostly it will work. So here you can see this, if you put x is equals to tan theta, then it will become tan theta, tan 3 theta. So if x is equals to tan theta, this means this will become 3 tan theta. If you try to see, I will be just directly using it. This will become tan 3 theta. Okay, so this means just 3 theta, and this means what? Tan inverse x. This will be what? Y prime means dy over dx. I will be using now y prime. Okay. So y prime means dy over dx. This means 3 divided by 1 plus x square. So your answer will be 3 divided by 1 plus x square. Simple. So you reduced your whole work. Otherwise you have to go by convention. This means then you have to derivate it. Then here you have to apply the chain rule and the quotient rule, and then multiply tan inverse x thing. Okay, the whole thing. So you reduced it in simple forms, which is by using substitution, and you get your answer in just 2 steps. Okay. Okay. Let us move to next problem. Problem number 11. Problem 11 says that again the inverse combination of inverse trigonometric function and some scary terms. So this means substitute it. So what you can think of directly, if you remember that if you substitute x, so you have 3 options only. Either substitute cos theta, sine theta or tan theta. If you remember the formulas for them, then you can directly skip that what formula you have to substitute. You can directly see by just expression. So I am seeing that if I substitute the tan theta, x is equals to tan theta, then it will become cos 2 theta. I know the formula. That's why. So this will be y is equals to cos inverse of cos 2 theta. So this will become 2 theta. This will become tan inverse x. Now the derivative will be y prime will be 2 divided by 1 plus x square. Very simple. See how quickly we got our answer. Okay. Okay. Simple. So in this manner you will get your answer. Now the 12th problem. Okay. So the also one thing is very clear. If you remember the ITF, the inverse trigonometric function chapter 2 class 12th, so it says that cos inverse cos theta will be theta when certain things is happening. This means this whole thing, first of all, this whole thing must lie in what? As you see that this whole thing must lie in the principal value branch. So cos 2 theta. So first of all, if x belongs to 0 to 1, so this means this must belong to 0 to 1. This means 0 to pi, theta must be from 0 to pi. Sorry, 0 to pi by 2. So 0 to pi by 2. Okay. I think 10. Yes. So if x belongs to 0 to 1, this means 0 to 1. This means tan theta. The x is what? The output of tan theta. Okay, so far so good. We know the tan theta graph will look like this. Tan theta graph will look like this. This means we want from where to where? We want 0 to somewhere 1. Just we want this thing. Just we want this thing. So this will be, as you can see, you will have some pi by 2 here. Okay, so far so good. And what you know, this pi by 2, as it is increasing, okay, so far so good. As it is increasing, this means the pi by 2 value at theta approaches to pi by 2, then you will get what? This as your answer. So this means indeed it is belonging to the principal value branch. So for this cos inverse, that's why we wrote 2 theta. We can directly use it. Okay, we can directly use it. Okay, so just do not get to the ITF for now. Just use this simple information. Okay, so forgot that. So simply use the substitution. You will get your answer. Okay, let us move to the problem number 12. So problem 12, against the substitution. If you try to see what is happening here, so what substitution you have to make? Quite simple. Put x is equals to tan theta. Obviously you are using x is equals to tan theta. Now what will happen? This will become sine inverse of cos 2 theta. Yes, as you can see, 1 minus tan square theta divided by this thing. And this can be reduced to what? This can be reduced to sine. Here you use cos 2 theta. Now sine inverse of this will become sine of pi by 2, okay, plus what you have to do is plus or minus, I will give you the reason, plus minus 2 theta. Okay, sine 90 minus theta will be cos 2 theta. Okay, sine 90 plus theta will give you theta, but one will work. Why? According to, if you don't know, the sine inverse of sine theta will be theta when? Only when this theta must belongs to the principal value branch of this function. Okay, so we will apply the only what? We will use the respective thing. Okay, we will use the respective thing. So you will know that what thing we will use. We will use the minus. You will know. Okay, from this you will know that this will be pi by 2 minus 2 theta. Using the minus, you know that this given condition will help you attain this thing. Okay, so this means, and this sine 90 minus 2 theta will give you cos 2 theta also. So far so good. Okay, now what you have to do, you have come to this thing. Now this will be tan inverse x. Now what? Now derivate it. By derivating you will get minus 2 divided by 1 plus x square. So your final answer would be minus 2 divided by 1 plus x square. That's it. Okay, so I hope that if you use the plus thing, yes, this will be same as cos 2 theta, but it cannot be reduced to pi by 2 plus 2 theta, this sort of thing, because of this given condition. Okay, simple. Okay, I hope that it is clear to you. Otherwise it will be out of the branch. Clear? So we are not going to in that detail. So for now just stick to the differentiations. That's it. Okay, clear? I hope that the solution is very clear to you. Okay, now let us move to the next slide. So problem number 13. So here reduce it. As you know, if you put x is equals to tan theta. Okay, if you put x is equals to tan theta, what you will have? As you can see, very simple. This will be what? Y is equals to cos inverse of, if you put x is equals to tan theta, then it will be sine 2 theta, and this can be reduced to what? In terms of cos, it can be easily reduced to cos, what can you what will be the answer? It will be the 90 minus 2 theta, the same approach, and this will be 90 minus 2 theta, which will be tan inverse theta, which will be tan inverse x, and if you differentiate it, you will get minus 2 1 plus x square, the same answer. Yes, you will get this. Okay, I hope that it is clear. So your 13th solution will be minus 2. Okay, minus 2 divided by 1 plus x square. Okay, now the 14th problem, let me just quickly end up this exercise 5.3. so the 14th problem, now what you will use? You will use the sign. X is equals to the sine theta, and this will be, quickly you will get 2 sine theta, and this will be 1 minus sine square theta will be cos theta, and this will be sine 2 theta, and sine 2 theta you will have now just 2 theta, and this will be 2 sine inverse x, and this will be y prime will be 2 divided by root of 1 minus x square. So the answer for this will be this thing. Okay, simple. Okay, now for the next problem, here you can use what? You can use x is equals to cos theta. Now using x is equals to cos theta, this will be sec inverse 1 by 2 cos square minus 1. Yes, 2 cos square minus 1, and this will be cos 2 theta, this will be sec 2 theta, and this will be just 2 theta. This means cos inverse x, and derivate it, you will have minus of 2 root 1 minus x square. Simple. So by just using these simple substitution, we either used tan or cos or sine, that's it. Mainly we use tan. So if you remember the formulas, double and triple angle formulas, you will get the answer correct and without any errors. Okay, so please do recall these formulas for double and triple angle formulas and the other identities also. And then you will, by just using substitution, you will get your answer very quickly. Okay, so that's it for now. I think we have covered every exercise, every question of this exercise 5.3. So thank you all. We will be back with the more theory of this continuity and differentiability chapter. So again, thank you.